Real-world application of finding the center radius form. So in this section, we're going to apply the equation of a circle to solve a problem. Locating the epicenter of an earthquake. An earthquake's epicenter is the point on the Earth's surface directly above the earthquake. Seismologists must gather data from at least 3 stations in order to plot the location of an earthquake. So the point where these 3 circles intersect on a map is the epicenter of the earthquake. So in the diagram shown, the point where all 3 circles touched at one point, that is where you consider the epicenter of the earthquake. Now suppose that receiving stations A, B, and C are located on a coordinate plane at 1, 4, -3, -1, and 5, 2, respectively. The epicenter of an earthquake is determined to be 2 units from A, 5 units from B, and 4 units from C, where the coordinate plane is the epicenter. So let's go ahead and write our 3 circles. So we were given the information of each center and radius. So for the first, it was located at 1, 4, A, and with A, the epicenter was to be 2 units from the A, so that means that you have center of 1, 4, 2 units from that, that would be your radius, or radius of 2. Respectively, with the same goes with B, your center -3, -1, with a radius of 5. The last one, C, center 5, 2, with a radius of 4. So let's go ahead and plug those into the equation of a circle form. So there's station 1, station 2 with its center and radius, and then station 3 with its center, radius, and all. Notice we plugged them in into the center radius form of a circle there. All right, so if we were to write them out, remember double negatives becomes positive. So writing each out, we have here our equations of our circles. Now the next thing I want to do is let's go ahead and graph these circles so we can actually see where the epicenter is located. So if we graph these points, we graphed over 1 and up 4. Then we moved 2 units, 1, 2 in every direction. That's how we got that circle. For B, our ordered pair was -3 and down 1. And that had a radius of 5, so we had to move 5 in every direction there and then form our circle. The last circle point was over 5 and up 2, and it had a radius of 4, and every direction we formed our circle there. So now we're looking at a point where's the point where all 3 circles here touch at one point? And if you look very closely, you can see that from the graph that it touches, or all 3 intersect at the location of 1, 2, over 1 and up 2. And so that is where we would consider the epicenter of the earthquake. We can check that to see if indeed is that where our epicenter is located. So here are all our three equations of a circle that we created. Let's go ahead and in the x's place, we're going to plug in that value that we got, 1, 2. So everywhere you see an x, plug in a 1, and for all your y's, plug in a 2. So if we do that and do the math, you're going to see that for each circle, each case, that it checks out and it leaves you with a true statement. And so when you can plug in your answer and have a result of a true statement, that is your proof that the ordered pair 1, 2, that it does lie on all three circles. So again, we can conclude that that is the epicenter of the earthquake.